Lewis structure, and I alluded to this yesterday. So this is 2.6. We're going to talk about something called resonance, and we're going to talk about formal charge. Okay? When we talk about resonance, resonance is when you can draw a structure and have two possible valid outcomes. So here, if I drew this NO2 ion here, which is the this is the nitrite ion. Okay, if I drew nitrite here, I could have the double bond for oxygen here, or I could have it here. Okay, this is called resonance. I need these brackets here. Why do I need the brackets? Right, because that indicates my charge. Okay, that I've got a charged ion, and then I put the charge out here. And then I indicate the resonance by drawing both of them and drawing an arrow to say that it goes back and forth. And in reality, what's happening is this electron's here, and then it's here, and then it's here, and then it's here. So you got a single bond, a double bond, a single bond, a double. So it's kind of like flip-flopping back and forth, okay? And because of that, we have to draw the resonance in to kind of show that sometimes it's here, sometimes it's here. Okay, yeah. Yes, sir. Well, you can have a positive charge, so then it would have one less electron, but this charge indicates, because it's negative, and it's -1, we just don't write the 1 down, that indicates that we have one extra electron. Okay, and if you count them up, you do, because nitrogen would have 5. 5 and 12 is 17. Well, we have 2, 4, 6, 8, 10, 12, 14, 16, 18. So there has to be an extra electron that's come into the party. Okay. All right. Does that make sense as far as resonance is concerned? All right. So resonance structures are present simultaneously. They don't flip between them. The electrons are described as delocalized, so they're actually kind of an average between them. Oh, here is a typo. Sorry. There we go. Sorry about that. All right. So the bond length, and we'll talk more about bond length in a little bit, but the bond length is going to be 1.5. So here, the bond length for this, the way you determine bond length, and we're going to go over this in much more detail. I'm just giving you a preview. You don't need to write anything down about it. I'm not going to be quizzing you on it tomorrow. Bond length here, we would count how many bonds we have and how many bond sites. So it's number of bonds divided by bond sites. So here I've got 3 bonds divided by 2 bond sites. Do you see that? So 3 divided by 2 is 1.5. Okay? So that's how we get the 1.5. Here, my bond length would be what? 1.5. Okay? This is ozone. Okay? All right. Formal charge. Mm-hmm.
I remember doing this online.
I remember that.
I remember doing the documents and retesting.
Doing the homework on the computer.
Literally, yeah, it's
the worst.
Type in all those subscriptions.
Yeah. The only thing I remember from that is not knowing the
Oh yeah.
and failing.
I remember trying to make the diagram in the document.
Change.
Okay.
Or the
So,
structure in the document.
there is a much more complicated way to do formal charge. Okay? The nitty-gritty one that works 99.9% of the time, and it'll work for your AP test, is this. Formal charge equals should minus has. That's what you got to remember. Now, what does that mean? Let's go through it. Okay? There are often times, and this goes back yesterday, you would ask me, how do you know that it goes this way instead of this thing? And I said, I'll explain that to you today. Okay? It all comes down to this idea of formal charge. So you can have multiple structures. possible, but formal charge is what you're going to use to determine what the best structure or the most likely structure is, because it comes down to this. You calculate it as should minus has. Should is the number of valence electrons an atom should have. So you look at the periodic table. 3, 4, 5, 6, 7. Good? Okay, so you know those. Minus has, how many do they actually have? Okay, the best structure is the one with the formal charge that's lowest as possible. You're hoping for 0. And you put a negative formal charge on the most electronegative atom. So if you have a choice, that's where the negative formal charge needs to go. And you're going to have to watch some of these to figure out how this works. Okay? Now, when we do a has, we count a bond as 1 instead of 2 electrons like we normally do when we're doing our thing. When we're doing formal charge, the bond only counts as 1 electron. I should write that in. All right, so let's go through one here. So we have total electrons here. This is kind of ugly here. It didn't get perfect here. All right, there's my pen. There it is. Okay. So we've got this guy here. Okay, this electron, these electrons should be right here. You guys can kind of visualize that, I think. Okay, let's count how many we've got. Okay, so we should have 24 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, what's a big problem with this guy? Carbon doesn't have an octet, so there's a problem there. Okay, so we need to figure out how we're going to draw this. So if we draw this with carbon here, here, and our oxygen down here. Oh, God dang it. How are we going to get carbon to a full octet?
No, double bond.
Yeah. Yep. Okay, so if I double bond this one, and then I do one of those coordinate covalent bonds here, now this has 8, this has 8, and this has 8, and carbon has 8. And how many electrons do I have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I'm good. All right, so now let's try to figure out what the formal charges are on these. Okay, so for carbon, carbon should have how many? 4. Carbon has how many? Remember, we count the bonds as how many when we do in our has.
1.
So 1, 2, 3, 4. So its formal charge is 0. For this oxygen, it should have what? How many? I don't want to mark these 1, 2, and 3. Okay, it should have 6. How many does it have? 2, 4, 5, 6. Okay, it has 8 as its octet, but when we're counting our has here, remember we only count these as 1. Okay, that's kind of the thing of this one. Now there's a much more complicated way to do it where you don't do that, okay? But this is so much easier. Like, go out and watch YouTube's videos about the way other people do this. Oh my God. Oh my God. I don't even know. It's a mess. I tried to figure it out my first year teaching this, and then I stumbled upon a video on how to do this, and I never looked back. I'm like, I'm not going back there again. Okay. So 2, 3, 4, 5, 6. So this guy is 0. Now, here, for this oxygen, it should have 6 again. How many does it actually have? 7. So its formal charge is -1. Okay. And our last oxygen, you can probably see, is going to be the exact same thing. Okay. So the formal charge for this whole thing is what? -2, which corresponds to this. Okay. If that ion has a charge on it, then that means that you're going to have a formal charge in the thing of that same amount. If not, it should be 0. All right, so here's our practice one. So let's practice with this guy. So determine the formal charges, and then we're going to figure out which one of these is best. So I'm going to give you a second for you to figure out the formal charges on all 9 of these. Okay, should minus has. Go. Then we'll talk it through. When you're done, drop your pen or pencil so I know you're done. And done means given up too. Okay, and that's okay. I don't expect you to understand how to do all this yet. I just want to know whether I'm ready to move on yet or not. Okay? You ready? Okay. So nitrogen should have 5, correct? Okay. So nitrogen should have 5. It has how many here? 7. 2, 4, 6, 7. So it is a -2. My carbon should have 4. It has 4. So it is a 0. My sulfur should have 6. It has 1, 2, 3, 4, 5. So it is a plus 1. My overall charge for this whole thing is a -1, which is what it should be. Okay? So that is the structure here. Let's look at this guy. This is, anybody not understand where I got these numbers from? Talk to me if you don't know where I got these numbers from.
I thought you said that we had to divide the halves in half, or divide it by 2, right?
Well, these, yeah. So these bonds, normally you would count these as 2 electrons, okay? But now you're just counting them as 1. So 1, 2, 3, 4, 5.
So just the bonds, not the lone pairs.
Correct. Okay? That's why we run through some of these. Just the bonds. And I think that's what I wrote in the notes, right? When I rewrote it. A bond counts as 1 electron, right? And that should have been in your notes. I'm sorry. All right, so nitrogen, again, 5. This time, 5 minus 1, 2, 3, 4, 5, 6 gives us a negative 1. Our carbon is still sitting at 4. 1, 2, 3, 4. And our sulfur, 6 minus 1, 2, 3, 4, 5, 6. So it is a 0. And we are at our negative 1 charge, so that makes sense. All right, last one that we're going to look at, and then we're going to figure out which one's preferred. So we've got 5 minus 1, 2, 3, 4, 5. That one's 0. Our carbon is 4 minus 4. 1, 2, 3, 4. And our sulfur is 6 minus 1, 2, 3, 4, 5, 6, 7. So it is a negative 1. Negative 1. Okay? So now we need to figure out which one of these is the most preferred. And that comes down to electronegativity. So which one of these 3 atoms is more electronegative? Yeah, well, it's a yeah, okay, yeah. No, nitrogen's more electronegative. See, it has a 3 here, and sulfur has a 2.5. So nitrogen needs to be carrying the negative 1 charge if it can. So here, yeah, it's carrying more of the charge than this guy. But if we can build the structure where that formal charge is only on 1 element in there, that's what we want. So we're going to get rid of this guy because there's formal charge here, there's formal charge there. We don't want that guy. Okay? Here, the formal charge is on the less electronegative element, so we don't want this guy either. This is the one we want because nitrogen is more electronegative. So you're going to have the negative electronegative charge, or the negative charge on the most electronegative element. Yeah. Not necessarily. Symmetry, I mean, is great, but it's more formal charge than anything. Like formal charge is big. Okay. All right. Let's see what else. Do I have another? Why is this not advancing? There we go. All right. So here, figure out which one of these is better. No, it doesn't have to be symmetrical. And sometimes it won't be. Sometimes your better structure will not be symmetrical. right, hydrogen should have,
1.
and it has,
1.
so it is,
0.
okay? Carbon should have 4, and it has 4. So what is it? 0. Oxygen should have, and it is, so it is. All right, over here, hydrogen, carbon, oxygen, we've already established those. Hydrogen should have 1, it has, it's sitting at 0. Carbon should have, it has 1, 2, 3, 4, 5. So it is at a -1. I'm leaving that. Oxygen should have 6. It has 1, 2, 3, 4, 5. So it is a +1. Okay, so which structure is better, 1 or 2?
1.
1 for a couple reasons. Okay, reason number 1, there's no formal charge on anything. That's what you want. Okay, but if you do have to put a formal charge on something, that negative value should always be on your more electronegative element. Here, it's on the oxygen, or it's on the carbon, and that's not good. Now, the overall charge or formal charge on this molecule is what? 0. Okay? 0 plus -1 plus 1 is 0. So that checks out, but we don't want this guy. Okay? Makes sense why?
Right.
Go ahead. Huh? We don't want it because, first of all, you can do a structure here where there's no formal charge on anything. And over here, remember, if you've got to have a negative formal charge or a formal charge, you want a negative value to be on the most electronegative element. Oxygen is more electronegative than carbon.
So you'd rather no element have like any charge at all?
Correct. That is your optimum. Okay.
Even if the total is 0?
Even if the total is 0. Yep. If you can build it such that nothing has formal charge on it at all, that's what you want.
Okay.
That is the absolute ideal. So that's an option. But sometimes that's not an option. Sometimes you can't do it. Like with this guy over here. We couldn't build this and make this work. It wasn't possible. So a negative charge had to go on something. And if that is the case, then the negative charge needs to be on the most electronegative element in that group. Okay? All right. So nitrate, if you guys don't remember what nitrate is NO3 with a -1 charge. Figure it out. What? Yes, I want the preferred structure. And if you want to get real fancy, you can do some resonance structures on it too. Ooh. I know automatically with this guy that he's going to have a formal charge on something. How do I know that? Just by looking at this. It's a -1, okay? And I know going in that that negative charge should be on what element? Not nitrogen, okay? So if that helps you at all with your planning. And if you're done with this one, move on to that. You've got like 4 more slides there to work on. Work on those. What do I have planned for more? Is it just the quiz? Was I supposed to lecture 2? Oh, just the quiz. That's nice. I think I'll probably just make the quiz 2-1 to 2-5.
Yes.
Yes. Please do that.
Okay, I'm going to do that.
Thank you so much.
Because you won't have practiced and been able to verify your answers with me before that. So that's why I want to back off on that. You're going someplace fun?
Oh, I'm going to Cleveland.
Oh. Some good restaurants there.
Wait, for Ohio State or?
No, Ohio State's not in Cleveland.
Going to Cleveland State.
Where's Ohio State? Is that in a small town?
I think it's in Columbus, isn't it?
Maybe, yeah. I thought it was like in a small town outside of.
Is hydroxide OH?
It's in Columbus, yeah, which is the capital of Ohio.
Yeah.
It's kind of in the middle of the state, I believe. We got a cool zoo there.
Maybe it's like top, no, top right. Hydroxide.
Yeah,
Are you
here's
sure?
the state. It's almost in the middle.
Nitrate has a -1 charge and a -2.
Nitrate has a -1 charge. Is that what you asked about? Or what are you asking? Are you asking about something down below?
No, I'm just trying to get nitrate a -1 charge.
Okay,
He's getting a -2.
so nitrate is going to have 5 here, and this is going to be 18 and 1. Okay, so that's 26 electrons. No, 8 and 6, 24. 24 electrons.
That's why it's a positive.
That's an extended outlet. Because you need 24 doses. If you have, so I have enough 10 to 4 something.
18.
1, 22. And nitrogen is 20. We have 5 double bonds.
Two double bonds are the same one.
I have 1 double bond, 2 single bonds. And that's liquid.
And then when you calculate it,
Oh yeah, I guess you could do it by oxygen.
what is actually 0?
All right, so I've got 24 electrons up here right now. What's wrong with this structure, though? Okay, so if I take 2 of these electrons and bring them in, okay, so I'm going to take these 2 and I'm going to bring them in, then nitrogen has an octet, this oxygen has an octet, this oxygen does, and this oxygen does. And I'm still maintaining my 24 electrons because I had 5 from nitrogen, I had 18 from the oxygen, and I have this 1 extra here, giving me a total of 24. Then I want to check my formal charge. So should minus has. Formal charge on this guy is what? 6 minus 7 is -1. Formal charge on this is -1. Formal charge on this is 0 and okay, so 5 5 is what it should have. It has 1, 2, 3, 4. So it is a positive 1. Okay? So these two cancel each other out, and that leaves this one remaining to give this formal
I had it
charge.
written down right.
Jacob.
I had it like that, but does it matter which oxygen has the -1 charge?
No. In fact, this is an example of that resonance. Okay, so we would draw this again, and this time we would flip the double bond over here, and then we would draw it a third time, and it would be down here. So that's your resonance. Okay, so you don't have to, unless they state, draw all possible resonance structures. Okay, so if they tell you to draw the resonance structure, you darn well better draw it. Okay, but unless they specifically state to draw the resonance structures, you don't have to. All right, so you've got the rest of these slides. So you've got all of this, and then what else do you have? I think I gave you one more worksheet for this guy, right? So yeah, you've got everything else up to 2.7 I want done by tomorrow. The quiz will only be through 2.5. I would like you to try to draw your Lewis structures tomorrow with formal charge, but if that's not done, I will still accept them tomorrow. But tomorrow's the last day. Okay, fair enough? What, Matthew?
Nothing, I'm just complaining.
Still got your Kleenex? You know where they're at.
Behind me.
Okay, well, you know where they're at, honey.
I know. I might need them later.
Maybe tomorrow.